All, all right. Welcome everyone back to MDE 54 in our 11th week. So I just want to remind you that your midterm was extended 2 days past when it was supposed to be. Remember, it was supposed to be Monday and Tuesday of this week. And my math lab was just having problem after problem after problem after problem. I mean, really, it was just the same problem, but it just kept having that problem. So we, sorry about that. We said instead of being the 29th and the 30th, we were giving you all the way through tomorrow, April 1st. And with that in mind, I figured we had a little free time between subjects. So what I wanted to use today for was to just go over some random problems from the review. So I'm gonna just kind of pick here, pick there. I'm not necessarily gonna go in order. And yeah, so again, just wanted to do some midterm review problems for fun. If you've already taken your test, then this could be a good way to remember things for the final. If you needed that second chance, this would be a great way to have additional review material. If you haven't taken it the first time at all because my math lab wasn't letting you take it, again, this is also a great opportunity. So let's go ahead and get into that in about 20 seconds.
All right, so we're going to do number one. And like I said, I'm not necessarily going to go in order. I'm not going to do all of them. I will be skipping a whole boatload of them. I may get down to like 55 and we're only 45 minutes in, and I'll go back and do maybe number three. But I'll start at least just kind of going down the list. So the annual interest rate for Jack's savings account increased from 1.5% to 2.3%. Complete parts A and B, which are to find the absolute change or total change in terms of percentage points, which we said we have to phrase that with percentage points when we're talking about change of percents, and then define the relative change, aka the percent change. And that would be kept as a percent symbol because percent change is always a percent. We just don't use the percent symbol for a total change because then it could be confusing. And that confusion happens when the numbers that you're originally given are percents. This doesn't happen a lot, but it certainly does happen. All right, so we have our new, which is the 2.3%, and then the old, which is the 1.5%. So the total change, or the absolute change, that's just another way of phrase it, is the new minus old, which would be the 2.3% minus the 1.5%. So the total change should just be 0.8%. Asterisk. We don't want to use the percent symbol for a total change, so we call it 0.8 percentage points. We can abbreviate that as PP. We can use the full words, percentage points. There's variations to this as well. That's the one you should see. And remember that this midterm review has answers, so you could scroll down. You don't have to do it yet, but you could if you're really, really curious, to the answer key. And I won't keep doing this because it'll just get tedious. And you can see that we have 0.8. Now, they didn't write the units because the units were already part of the answer block. See, percentage points. And that's been the kind of the common denominator, so to say, in my math lab. I've said that a lot of this, make sure your units are there, really only comes up in certain things in our assignments, but it's extremely important in the real world. All right, so then our percent change, what they're calling the relative change. So relative change or percent change. It's always silly when that happens. Percent change. Well, that's the total change divided by the original or the old, but then you convert it to a percent. So for this one, the total change was the 0.8 percentage points, and that was an increase because it was positive, divided by the original, which was the 1.5%. Now, even though percentage points and percent, I'm not saying the same words, I didn't write the same thing, those are the same thing. They're just named differently to help you distinguish the difference. So those two things will cancel, and then we can just do 0.8 divided by 1.5. 0.8 divided by 1.5. And we end up with 0.5333333, but then we have to convert that to a percent, which we said the easiest way, so you don't have to worry about any rounding. You just take that and multiply it by 100, and boom, there's your percent. So it's 0.53 bar, with the bar just over the 3, which converting that to a percent becomes 53.3. Let's just round to the nearest tenth. That's what they told us to do, percent. So that should be the answer there. And if you scroll back down, it would confirm it. I can guarantee that. Remember, just because you see a percent somewhere does not mean you're doing percent change or even total change. You have to understand the context of the problem. You have to know which simple math, we'll call them formulas, but I prefer to call them concepts, to use. If I give you a problem where I'm asking, where I say, all right, here's your old amount, and then there was this percentage increase, and find me the new amount, then you've got to do new equals the old times the growth or decay factor, where the growth or decay factor is 1 plus or minus the rate given in terms of a decimal. All right, I have actually done this question number 2 previously, so I'm not going to do it again. An airliner, number 3. An airliner travels 25 miles in 3 minutes. What is the speed in miles per hour? So, oh, here's a distance, here's a time, and speed is always a distance over time. That's literally a formula. But you don't even necessarily need to know that. If you see the units, you can see it's distance over time. So here's a distance, here's a time. So we just need to figure that out via a division. So our speed would be the 25 miles that we go in 3 minutes. And that doesn't divide perfectly. So they say they don't actually say anything about rounding. So interesting. But you could divide that if you really wanted to, and I'll show it, but ultimately I'm not going to keep it. So 25 divided by 3. And you get 8.3 bar. And the fact that they didn't tell me to round is actually a clue that says, that must not be right. So why isn't that right? Because the bottom, the units that we see are in minutes, but they want us to have the answer in miles per hour. So we need to do some dimensional analysis, or we need to set this up as a proportion to convert the dimensions from one to another, whichever way you like, I don't care. But you know me, I prefer dimensional analysis, out with the old and with the new. So we multiply by a fraction in such a way to get rid of the old units that we no longer want, which are minutes. We don't want minutes anymore. So since the minutes here are originally in the bottom, they must go in the top of our multiplier. That way they'll cancel. And the thing we're trying to convert to is hours, and we should know how many minutes there are to how many hours. In particular, 60 minutes is 1 hour. Again, I'm not going to give you anything having to do with time, and there will definitely be time conversions on this test. So when you do that, your minutes will cancel. And you could even take the 3 and the 60 and reduce them, since one's in the top and one's in the bottom. You could let the calculator speak for you, but I'm going to show the work. 3 goes into 3 once, and 3 goes into 60 20 times. So then we're just doing 25 times 20, which is going to end up being, I'm sure you could figure that out without it, but just for fun, it's a pretty big number, 500. So that says that this is 500 miles over hours. The miles are in the top, the hours are in the bottom. In other words, 500 mph. The only time we ever abbreviate miles with just an m is for mph. Otherwise, m means meters. The true and regular abbreviation of miles for probably the 10th time this semester is mi. So 500 miles per hour would be your answer. And you might think, well, that doesn't make sense. How is anyone traveling 500 miles an hour? Well, they didn't say what they were traveling in. They didn't say they were walking. They didn't say they were running. They didn't even say they were in a car or in a train. Maybe they're in an airplane, and airplanes most certainly go 500 miles an hour. I have a silly 80s song in my head now because of 500 miles. If you don't know it, that's okay. All right. 4 is a little too easy. I don't want to do that one. I mean, this is really just, they say talk about the ratio of transportation to total budget. So you just got to take the transportation number, write it over the total budget. They didn't give you the total budget, so I'm pretty sure you can figure out how to get that. Divide them, reduce them, and boom, there's your answer. I'm not going to do 5. Let me get to that in maybe 10 minutes. Yeah, well, as we get to it, we'll do that. Sure. You must decide whether to buy a new car for $20,000 or lease the same car over a 3-year period. Under the terms of the lease, you can make a down payment of $2,000 and have monthly payments of $250. At the end of the 3 years, the leased car has a residual value, which means the amount that you pay if you choose to buy the car at the end of the lease period, of $13,000. Assume you sell the new car at the end of the 3 years at this residual value. Is it less expensive to buy or is it less expensive to lease? Now, if this was the real world and your credit isn't just absolute trash, leasing 99% of the time is more expensive. There's a reason car companies offer leases. It's because they can make a little more money on top of everything in the long run. They can nickel and dime you to death along the way too if you drive too many miles, if you get dents and dings and things like that, but not the point of the problem ultimately. We're just going to stick to the pure math. So number 6. Always do that. All right. So the new car costs $20,000. So new, it's 20K. After 3 years, we can sell it for the residual value, which is $13,000. I'd say that's a pretty normal depreciation of a car value. If you get like a 2019 Honda Civic for about 20 grand, not a lot of options in it, obviously. It's probably going to lose about $7,000, $8,000, $9,000 over 3 years. So that would mean it's worth $13,000 and you could sell it and then you'd have $13,000 in your pocket. Now, this assumes that you had the $20,000 to begin with. So you walk into the dealership holding 20K, fat stack, slap it on the table, you walk out with your Civic. And then 3 years later, just on Craigslist or on Facebook Marketplace or wherever, you don't take it back to the dealer because they're going to offer you way less for it. You sell it on your own and you get $13,000. So the true cost, if you paid cash, is going to be what you paid up front minus what you got back, because after 3 years, now you have $13,000 back in your pocket. So you didn't pay that full 20 grand for the car. Now you had other things like insurance, gas, repairs, etc., all that to consider. But at least when you threw 20 on the table 3 years ago and now you're going to walk away with 13, that means that your true cost, ignoring all other costs of the car, is the difference of what you paid and what you sell it for, which is $7,000. Now that's if you bought it with cash and you sold it and got that $13,000. That's the true cost after you're done with the car. Now, while you have the car, you're still out the 20 grand. But 3 years later, now you're back up. You have your 13. And maybe over those 3 years, you saved another $7,000, $8,000 somewhere and you can buy a brand new car again. Maybe that's not my suggestion for personal finances unless you're making a 6-figure salary. But again, not the point of the problem. So now let's go to the other scenario. That was the simple scenario of just buying it for 20 grand and then selling it. Now let's go to the leasing, because this one's a little more complicated. To lease the car, you put $2,000 down. So when you walked in, you didn't have 20 grand, you only had 2 grand, and they said, well, how about a lease instead? We'll take your 2 grand, and then you just make some monthly payments. Now, you have a third option, which is to get a loan. You put a small amount down, and then you're paying off the loan, and then after 3 years, 5 years, something like that, the car is yours. But when you lease a car, it's not actually yours. You're just borrowing it. That's all you're really doing. And again, there are some contingencies under the borrowing contract that you can't drive it too far, you can't modify it, you can't put new 20s on the tires or anything like that. Okay, so what is this lease scenario? So we got to put 2,000 down. That's a fixed value. We're going to pay that 2,000. And then we have a variable value that we're going to pay every month, $250. That's $250 per month. So I could actually set up a total cost equation for this. That's not the point of the problem, but I could do this if I wanted that. For any month, your total cost would be the variable amount, 250 times X, and then plus the fixed amount, your down payment of 2,000, where X is in months. So if you own the car for 0 months, that means you just paid the $2,000 and walked away. That's kind of weird. Don't do that. If you own the car for 1 month, you would pay the $250 because 250 times 1 plus the $2,000 for $2,250. If you own the car for 2 months, you'd pay $500 for the monthly fees plus $2,000 for the deposit, and that's $2,500. If you had this car for 4 months, you'd be paying $1,000 for the monthly fee and then $2,000 for the deposit for a total of $3,000. But we're paying this for 3 years. I did say 3 years, right? Yes, 3 years. So after 3 years, your total cost would be 250 times 3 plus 2,000. Now I said you don't have to do it this way. Some people can just play with the numbers and come up with this, right? And I'm doing this wrong intentionally because 3, that's 3 years, but the 3, this is supposed to be representing months. So no, this is not right. So what are we actually supposed to do? We got to convert, oops, I erased too much there. We got to convert our years to months. So 3 years ends up being 36 months. If you don't trust me, I'll show that math in a second. 3 years is 36 months because 12 months is 1 year, 24 would be 2, 36 would be 3. All right, so we can pull out our calculator and we'll go 250 times 36. This will be how much we pay in our monthly fees. 250 times 36, not 360. And we get $9,000 plus the 2,000, which is 11,000. So our total cost to lease is 11 grand, but our total cost to buy was 7 grand. So notice what else they said, and this isn't part of the problem, but this really shows you where the lease gets you. After those 3 years, they say that you can buy the car off of them for the residual value. So you've paid 11 grand to this car company, and then you can now pay 13 grand to own the car outright, and you will now have paid $24,000 if you wanted to continue owning the car. Now, you could still sell it for 13 immediately, and then you'd get your 11 back. I'm sorry, you could sell it for 13. Yeah, and there's your 11 from the lease. But you still are in the negatives. So what's the point of this? The cost of buying the car and selling it 3 years later, that was the $7,000. Again, yes, we paid 20 initially, but we got 13 of it back after 3 years. So the true cost to have owned that car for 3 years and then get rid of it is 7 grand. Now in this scenario, we're just gonna say, all right, we're getting rid of the car, we're not gonna buy it, we're not gonna release it, it's gone. So we paid the company 11 grand to lease it, and then they just take it from us, which means it is more expensive to buy in this scenario, and it's more expensive by $4,000. If you subtract them, you can see, red please, it would be 11K minus 7K. I had the 4 in my head, is 4,000. This is the extra cost to lease. Now, Mr. Beckner, I don't have $20,000 to go drop on a brand new car. Like I said, you have the option of a loan. Loans, if your credit's not awful, don't always require some big giant down payment, maybe $1,000 or $2,000. And if you don't have that, try and work towards getting that. That's definitely one of the American people's major issues, is not having $1,000 in a bank account somewhere. Something like it's either 9 out of 10 or 19 out of 20 Americans couldn't handle just $1,000 bill that comes up randomly, and that's terrifying. But again, the extra cost to have leased this car would have been $4,000, and I am very, very confident that if you got like a 3% car loan, if your credit's okay, that you're not going to pay $4,000 just in interest to that car company plus fees for the loan and everything. It's probably going to be in the ballpark of like $1 to $2 grand, generally speaking. And you can even go back to that car loan problem from chapter 1 we talked about way long ago, and see that table of information, and it agrees with what I just said. All right. Let me put my eyes on 30 just so I know what to expect later. Someone asked about 30. All right, cool. Yep, we'll get that. We're going to skip 7. We already did an absolute change and percent change. 8 is very similar to the first one we did. It's just that these numbers aren't in percents, which means we don't need to use percentage points for the absolute, aka total change. And then the relative change is just the whatever that answer was divided by the original. So to get the absolute change, you would be doing the new minus the old, which would be the 1212 minus the 2198. And then that would be a negative number, obviously. And then you take that answer and divide it by the 2198, convert it to a percent, and you would get that answer, which you can see in the answer key. All right. Number 9. Sure. Okay. And then we'll get to 15 as well. Come on, Tom. Let me make sure I got time for all those. Okay. Stop that. Not y'all, the technology. Convert 22 meters per second, which is meters over seconds, to miles per hour. Physicists, engineers love meters per second as measurements because these are much smaller scales, a much smaller distance, and much smaller time frame. And they like to think in instantaneous values. Miles per hour is a much more common way of talking about a speed of something, but miles is a long distance, hours is a long distance. If you're only going to move something 10 feet or like 3 meters roughly, you might want to measure it in meters per second instead, because you're probably going to get it done really quickly, and it just might make more sense for the context of the problem. But anyways, we're converting from meters per second to miles per hour. So the meters need to turn into miles, so we're going to need to know how many meters to how many miles. Well, oh, it booted me. That's all right. I'm just going to pull up one of my classes. Why is that so zoomed in now? The formula sheet. Here we go. Look at that ridiculously short formula sheet, which again is really just a conversion sheet. 1 mile is 1609 meters. This is a rounded value, so the answer that you see in the answer key may not be perfect. And on the test, if it doesn't take the answer, if I had a question like this on the test and you were off by like 0.1 or 0.2, that's another thing. You can shoot me an email and let me know, and I will give you full credit for that, because again, there's like a 0.1 blah, 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 blah in this that I'm just keeping it rounded to the nearest whole for the sake of simplicity. So 1 mile is 1609 meters. So we're definitely going to need that. 1 mile, 1609 meters. So we have miles, right? No, we have meters. M is meters, MI is miles. So we're going to multiply by a fraction to get rid of the meters. Meters are originally in the top, so put them in the bottom of the multiplier. We're going from meters to miles, and we know it's 1 mile is 1609 meters. So the meters will cancel. You could process this and get a number, but I'm not going to, because there's more to do. This time is in seconds, and we wanted our answer in per hour. So we got to go from seconds to hours. Well, we don't know how many seconds are in an hour. Well, some of you might know, I know. But in general, most people convert from seconds to minutes and then from minutes to hours. So seconds are in the bottom, so the multiplier, they go in the top. We're going to go to minutes from there, and 60 seconds is 1 minute. And then that will cancel the seconds. So now we're in miles per minute, but we need to go to miles per hour. Minutes were in the bottom, so they go in the top of our multiplier. M, MI, and MIN. Boy, isn't that fun. And we can go from minutes to hours quite simply because 60 minutes is 1 hour. The minutes are gone, and we'll get our ultimate answer. Calculator. So we're taking the 22. We're going to divide it by the 1609. Then we multiply it by the 60, and we multiply it by the other 60. Which, by the way, there's 3,600 seconds in an hour because the 60 times 60 is 360. Excuse me, 3,600. Blah. There are 3,600 seconds in an hour because 60 times 60 is 3,600. And we end up with 49.2 if I round to the nearest tenth, and that would be miles per hour, or 49.2 mph. So let's see what the answer of that one looks like. Since I said it might not be exact, I just want you to understand that I'm not a liar. Oh wow, this one actually was pretty dead on. Well, they have 49.20 to be fair. Did they say to round to the nearest hundredth? So if they said to round to the nearest hundredth, I might not have paid attention. That's on me. It would be 0.22 instead of 20. Let's see. They did say round to 2 decimal places, so that's on me. So I got 49.22, but they said the answer is actually 49.20. That is because this 1 mile is not 1609 meters. If you just go to Google, check this out, convert miles to meters, it's actually 1609.34. And honestly, if you wanted to put that 0.34, if you wanted to add that to your formula sheet so that you made sure you got the answer correct, that's fine. But like I said, I wanted to leave that as a whole number just because it really doesn't make a significant difference. And again, if my math lab marks you wrong on your test, shoot me a message. I'll see that you're only off by 1 or 2 hundredths, and I'll obviously give you full credit for that. So hopefully that doesn't cause any stress. All right, we're skipping 10, we're gonna skip 11. 12, cost analysis. We'll do this one and then we'll get to 15, and then we'll start working our way to 30. Wow, come on. That was why the zoom was off. Okay, now I know why. 12. Decide of the 2 given prices, which is a better deal, and explain why. We got 6 ounces of shampoo for $3.59 or 15 ounces of shampoo for $11.89. So scenario A, remember cost analysis, we take the cost, not say scenario A yet, it's just the whole thing. Cost analysis is always the cost divided by how much you get. And I say that very loosely. Quantity, a total, anything like that. So for scenario A, we've got a $3.59 cost, and that gets us 6 ounces. It might be fluid ounces, it might be ounces. I'm assuming it's ounces. They probably wouldn't measure that in fluid ounces. It is a fluid, but doesn't matter. And that comes up to 359 divided by 6. 0.5983, blah, 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 blah. And they say to round this to the nearest cent. So rounding to the nearest cent makes it 0.598, so 0.60 actually. So 0.60, and that's dollars per ounce of shampoo. So you're paying 60 cents per ounce of shampoo if you buy brand A or size A. If you go with option B though, maybe it's just a bigger version of it, you're paying $11.89 for 15 ounces. And then you do that division really quickly. 11.89 divided by 15. And we get 0.792, blah, blah, blah. So rounded to the nearest penny would be 0.79. And that's per ounce. So what would you rather have? I would rather pay less, so this is the better buy. And then you can fill your answers there. Now, make sure you select A or B correctly if this is on a test, because if you put the answers correctly, but you select the wrong one of being a better deal, the entire thing is going to be marked wrong. Another case of email me, point it out, I'll give you some credit, but I'm not giving you all, because sure, you did the cost analysis correctly, but if you make the wrong conclusion, that's a problem. And you have to make sure you're doing the cost divided by how much you get. Yes, you can do cost analysis with this upside down, but then you want the larger value instead of the smaller value because you'd want to get more per dollar. And it just makes it seem a little weirder. 14 is a really interesting one, just FYI. And I say it's really interesting because trying to predict the graph that represents temperature throughout the day, you've got to think about when is it cooler and when is it warmer. And we're going to think about in terms of, they say, the desert. So we're not necessarily thinking about our area. We're in a desert, which deserts swing temperatures pretty wildly. But like our area, it's cooler in the morning and at night and hotter in the daytime. So they say if this graph starts at 8 a.m., it's probably going to be one of the cooler parts of the day. And then as the day goes on, it's going to get warmer until eventually it hits its peak, and then it'll start cooling down, which tells me that B and C are out. Right? Well, no, because this is showing that it's getting cooler from 8 a.m. on, isn't it? This is like 9 a.m., 10 a.m., 11 a.m., maybe something like that. It's not going to get cooler from 8 a.m. up. At 8 a.m., the sun is out. It's already going to be increasing. So in fact, A and D are out. I was trying to play with y'all a little bit right there. So it's got to be B or C. And you go, well, wait a minute, these are the exact same shapes. So aren't B and C the same thing? We'll look more carefully, get your bifocals on. This graph has time on the y-axis and the temperature on the x-axis, whereas this graph is flip-flopped. It's got the temperature on the y-axis and the time on the x-axis. So we've got to think about, what are we basing all of this off of? We're basing it off of time. We're getting the temperature based on time, and the thing that we're basing off of is always the horizontal axis. So it would be B, because we're saying as we march forward in time, the temperature will go up. It'll hit its peak probably about 2 p.m. and then start going down until it hits its minimum sometime at dark. So again, the shape of C is correct if you flip-flop these variables, but this way it actually doesn't make any sense. So we're saying as time goes on, what is happening here? This C makes no sense at all. All right, 15. So far, I am taking 2 requests. I do reserve the right to turn down requests, though. There are a couple that if someone requested, I wouldn't do them for reasons, and I bet you could probably guess why. Maybe they're on the test. All right. I'm not saying that any of these aren't on the test. It's just there's a couple that I don't want to do because you would get the answer on the test instantly. That's all. Let's say this problem was on the test. It'll be different numbers. It'll be maybe even a slightly different context, potentially. So even though I'm showing you it's not an end-all be-all. All right. What is the purchasing power of $1 in 1977 in terms of $1985? So this is where, and you might think this is a proportion table, but it's not, because it only has CPIs. It doesn't have another type of data in this thing. This is just going to be used to extract the CPI values. You could make up your own proportion table if you wanted, but you are not using these years for any numbers. Years are labels unless we're talking about changes like we were doing today in class. So we're talking about comparing a cost to a CPI. So $1 back in 1977, how much would that be worth in terms of $1985? Well, in 1977, the consumer price index was, I hope that says 60.6. So in 1977, the CPI is 60.6, not 6.0, 60.6, and we had $1. Then in 1985, the CPI, the Consumer Price Index, remember this is just a way of gauging price of any good. And yes, it doesn't work for always work for specific goods. We talked about how technology tends to get cheaper. Fun things like concerts and movies tend to get more expensive. Consumer necessities like your fruits and veggies tend to stay flat or even go down. Milk, that went down significantly over time unless you're buying organic. All right, so 1985, that CPI was, I wish you could see how close I am to my screen for this, 107.6. And we don't know that dollar cost. Well, I mean, if you really need to see it, this is literally a proportion table. So you could draw your box around this if you wanted to, and then just do all your cross multiplying and jazz. If you don't need to show it as a table, you've got the values for 1 year, dollar CPI. You've got the values for another year, dollar CPI, and then you can just set up a fraction equal to a fraction, and then just go dollars over CPI or CPI over dollars. Doesn't matter. I'll go CPI over dollars. Now you got to compare year to year. It can't use the 1977 CPI and the 1985 dollars. So I got to go 60.6 over the one, sorry. I was about to do it like a proportion table, which would have been fine. It just wouldn't have been to this standard. Over the dollar amount, which is $1. And then we're going to set that equal to 107.6 over X. We will CM, which means cross multiply, which will give us 60.6x equals 107.6. Then we will divide both sides by the 60.6. We pull out a calculator. 107.6 divided by 60.6. And we get 1.775 blah, blah, blah. Of course, they tell us to round in the nearest cent, so 178. So that means $1 in 1977 is worth the same as $1.78 in 1985. So if you have a good that is inflated exactly according to the CPI tables, you would need $1.78 to buy that good in 1985, whereas you'd only need $1 in 1977. Now you might say, well, man, that makes me want to go back in time and buy the good for $1. Well, if your salary is inflating to the inflation rate as well, which not all jobs do, thumb pointing in my direction, many are often quite worse, again. But if you were getting raises that were exactly the same as a CPI change, then that means if you buy that good in 1977, maybe you're buying a loaf of bread for $1 in 1977, and then you buy it for $1.78 in 1985, the true cost to yourself never actually changed. If your salary is increasing proportionally, if your goods are increasing proportionally, then nothing actually changes. But we know in the real world, when you're looking at individual goods, they tend not to follow CPIs exactly, which is why we're not talking about one specific good. We're talking about the purchasing power, which is accounting for every single good possible, whether it's food, clothing, electronics, cars, homes, anything. All right, how are we on time? I got about 20 minutes. I will go ahead and scroll to 30 so I don't accidentally not get to it. Thank you for your patience on that one as well. 30. In one class, homework is worth 40% of the final grade. Each of 3 projects is worth 10%, and a final exam is worth 30%. So this is going to use that weighted average formula. So remember, your weighted average is going to be it's a sum product. It's a product of the weight times the value, or data times the weight, plus the value times the weight, plus the value times the weight, until you get all of them. And then that's just over the sum of the weights. Sum of the weights. This is one of those things that we only do it in 2.2 and then we never come back to it. So a lot of people forget this formula, but I love to throw it on the midterm, and whispering, I might even like to throw it on the final. Because if you're in college, guess what? Weighted average is your life. And I know I gave you a nice Excel file for our course that I said you could potentially adapt for other courses, but it's still nice to be able to do this by hand to understand it. All right, so we got a bunch of different categories. We got homework at 40%. We got projects, 3 of them, 10%. So that's 10%, 10%, and 10%. And then the final were 30%. So under scenario A, our student has an 88 homework average, a 96 on the first project, and that's it. So our weighted average is going to be an 88, that's our homework, times the homework weight, which is 40%. Remember, you can write this as 0.4 or 40% as long as you're consistent in the bottom. Then plus, we earned a 96 on the first project, and that's worth 10%, and that's all we have. Then we divide by the sum of the weights, just the weights we're using, which are the homework and the first project only. All right, so I can actually do this in the calculator all at once. And since in class I showed it step by step, I'm going to do it all at once now. So to get that top all in one thing, I need a parentheses, 88 times 40 plus 96 times 10. Close the parentheses, divide it by, open another parentheses, and then 40 plus 10. If you don't like the way I'm doing this, you don't have to do it. You can do the top, write the number down, do the bottom, write the number down, then divide. And we get 89.6. So that would be our average up to this point. This makes sense because we've earned an 88 and a 96, which means our grade should be somewhere in between those. If we came up with like a 70, that would not make sense because we don't even have any grades that low. If you came up with a 70, that means you're probably either confusing the weights with the data values in the bottom, or you're accounting for some weights that shouldn't be accounted for. Have other things to account for. Our weighted average, which we want to be an 80 overall. We still have our 88 on the homework. We still have our 96 on the first project. But now we have a 79 and a 72 on the other projects. I need the full space. So again, this was the homework. This was project 1, project 2, and project 3. But they want to know what is the lowest score we can get on the final exam, not what's the lowest score overall. What's the lowest we can get on the final exam in order to get this 80? So we don't know what that grade is, so we have to call it an X, and we're going to multiply it by its weight, which was 30%. And then we divide by the sum of all the weights, and now we are taking all of these things, so that was the final. So it is still 100%, the 40 plus the 10 plus the 10 plus the 10 plus the 30. I'll write it. All right. Now we can't forget about the 80. We still have that 80 over there. The bottom is going to be 100%. And then the top, the 88 times the 40, let's show what all that stuff is going to be. 88 times 40 plus 96 times 10 plus 79 times 10 plus 72 times 10. Let me check my numbers. 88, 40%, 96, 10%, 79, 10%, 72, 10%. Now I don't add up the X part because it's not a like term, so that's 59.90. But then we still have the plus the 30% times the X. This is an algebraic equation that we have to solve. And it might not be the prettiest algebraic equation that we've solved in here, but it's also not the end of the world. If this denominator is 100, the way you get rid of denominators with fraction equations is you multiply both sides by that. So multiply both sides by the 100%. So 100 on the left, 100 on the right, times the 80 equals, and then times that entire fraction, 5990 plus 30% of x, all over the 100%. And that's because things top and bottom cancel. That's why we do that step. Now, here's a cool way we could have avoided this. If instead of doing percentages, you did decimals, the bottom would have been a 1, and then it wouldn't even be there, and you wouldn't have to worry about that. And I am 100% confident that when I did a problem like this back in 2.2, that was the way I did it in that class, and I made the suggestion to do it that way because of that. But you may forget that, so here's the different way, and that's why I chose to do it the different way this time. So 100 times 80 is 8,000. And then that percent symbol is still, you can just kind of drag away in the end. Plus the 30x. We're going to subtract the 5990 on both sides. Doing our basic algebra, which is going to give us 2010. Equals, sorry, 30x. Then we divide both sides by 30. And that should divide perfectly. 2010 divided by 30, or just 201 divided by 3, and you get 67. 67 is x, and that's the lowest final exam grade to get a B, because an 80 would make a B. And thank you for correcting me. Thank you for tolerating the earlier problem, but at least you get a twofer. Another thing you could do is if you are extremely what's the word I'm looking for? If you believe you're going to do the best possible, you could say what's the best possible that you haven't gotten that. And I would assume that it would be higher than an 89.6 because more hundreds would pull that. So we need a 67 to get a B with those project grades. Now, if we earned higher project grades, maybe we would need a lower final exam grade because then things can balance out a little more. All right, I only have like 7 minutes. Not that page. There it is. There was one before 30 I wanted. Number 26. Because this uses the other style of equation for proportion. Now, I'm going to do it the other style, that is to say, but you don't have to. You can go fraction equals fraction. You can go x's over y's. So I'll do that afterwards, but we say y varies directly with x. When we see that phrase, we usually write y equals kx. Y varies directly with x means that y is equal to some constant of proportionality, some number times x. And they say when y is 8, x is 4. So we go 8 equals k times 4, or 8 equals 4k. We'll divide both sides by 4. And that tells us that the value of k is and always will be 2. So the y equals kx turns into y equals 2x. Basically, for every 1x, there are 2 y's. So what about when x is, what does that say? 8. Well, y is equal to 2 times 8, which is 16. And that's it. Alternatively, if you don't want to use the proportion equation, which if they said inversely proportional, you would have to. Remember, inversely proportional or varying inversely is not the same as direct proportions. That's k over x, and that's when you can't do what I'm about to do. You can't do a fraction equal a fraction. So I'm going to go fraction equal fraction instead, since direct variation means proportional. This is an alternative method. And I'm going to go x's over y's. So one scenario was when y was 8, x is 4, so that's 4 over 8. And then the next scenario is find out what happens when x is 8. So that's an 8 over an x. You will cross multiply. You'll get 4x is equal to 64. You're going to divide both sides by 4. And guess what 64 divided by 4 is? I wrote y. That's kind of a confusing letter, isn't it? I wrote an x here for an unknown, but I'm calling these x's. So that's probably a bad idea. Forgive me for that. Let's use n instead. So when we divide both sides by 4, the unknown value, which is a y value, is still 16. Again, because there was no context here, no apples, oranges, we were just using y's and x's. Calling these things x and y top and bottom, you don't want to call something that's in a y position an x. That was a bad idea on my part at first. All right, one more good problem. A lot of proportions. 36, that's a good one, but I'm not going to do it converting minutes to seconds. We've already shown about going from seconds to hours, so hopefully that would be a pretty easy one. That's another proportion. 39 is another time one, but this is on a much longer scale. You'll have to do several conversions. I don't want just a multiple choice one. And I'm trying not to do just a basic proportion one. Here we go. 45 is an excellent one because people always want to answer 45 wrong. The population of a city was about 175,000 in 1980 and has decreased by about 1,000 per year since then. So this city has 175,000, but their city managers aren't running it well, so people are leaving, or maybe they just ran out of space. So in 1981, they will have lost 1,000 people, which means so years since 1980 and population 0, 1, 2, 3, 4 T. So to get each of these populations, what we're doing is we're taking the original one and then we're subtracting an extra 1,000 each year. So that's the variable amount. This is the fixed amount. So our total, remember, it's always the variable amount plus the fixed amount, or fixed amount plus the variable amount. I do fixed first for a reason, because this is a subtraction, so it's just going to feel more natural. So we always start with that 175K, but we're subtracting, because it's a minus, we're decreasing, 1,000 people per year. Now I can't just say 1K, because that would just be the total 1 year later. I want to have this represent all years possible. So that's why we said for that variable amount, we need to multiply it by that's right, a variable. Now they are using the letter T for time instead of X. So that is actually our formula, 175,000 minus 1,000 T. So without Ks, 175,000 minus 1,000 T. So the population in year 0 is 175K. The population after 1 year is 174K. After 2 years, 173K. Excuse me. Another year, 172K. Another year, 171K. And then someone's going to go 170K here because they're not paying attention, and that's wrong. And that is because that does not say time 5 years in, that says time T. What is really supposed to go here is 175,000 minus 1000t. It's supposed to be the actual formula. That is what a lot of people mess up. And then for part B, they say to find the population in thousands when t is 24. So when t is 24, then our population would be 175,000 minus 1,000 times 24, which is 175k minus 24k, which is 151,000. Now, I think in the answer key, they write the answer to the population is a little weird. What number was that? 45. See how they set it up? Now they're doing everything in thousands, actually. My answers are in wholes, so it's 175 minus 1t. That was this, so it's not in thousands. And then the population would be 151, and again, that was in thousands. So they just have these answers expanded, because that was 175 minus 1 times 1, 175 minus 2 times 1, just plugging in the time. Now, the fact that I have the 1 before the t, they have the t before the 1, doesn't matter, it's the same thing. 5 times 7 is 7 times 5. So that one's got a little bit of a wackiness to the answer, but it's not anything complicated. It's just setting up a fixed and variable linear model and plugging in some numbers for it. That's all it is. All right. And let's finish with this 56. 55% of 640 guests is what? That's what they're asking, is what? 55% of 640 guests is what? So this is not a total change, percent change problem, even though you see percentages. This is not an old times growth factor equals new, because they're not talking about an old and a new scenario here. Context is important. This is just finding a part and whole proportion. So we go fraction equal fraction, where one side is part over whole, and the other side is the percentage over 100. Well, we have it 55% over the 100%. Now the question is that 640 the part or the whole? Well, I gave you a clue that the thing that comes after of is the whole. So 640 is what goes in the bottom. If you know another way to set this up using of being times, is being equals, that stuff, that's fine too, but this is how I teach it in QR. And that would make this our x. We can cross multiply, and we'll get 100x is equal to whatever 55 times 640 is. Big number, 35,200. Then we divide both sides by 100, which clearly gives us x equals 352. And that makes sense, because if we want 55% of a population, that should be about half of the population, and 352 is in the ballpark of half. So it's a pretty good sign. All right, so I hope
All right, so I hope this was helpful. Again, I know some of you will still need to take that test due to the technological issues, so I figured this would be a good opportunity for those of you. Per usual, if you have any questions, please hit me up over email. What did I need to say? The last thing is that there's going to be another situation where I'm going to have to cancel this class. The Math 154 should be fine, I think, but I had another appointment that I just can't get around. So I don't even remember what day it is. So we'll talk about that next time. But for now, have a good day. Email me with any questions. And then after you're done with your test, have a good weekend. Hopefully you get to relax before you get back to the grind. Take care.